Yeah, so for everybody, we are going to record this. Don't let that kind of be a shielding factor. We're going to edit it before uploading it and all that stuff. So it's all good. So today's training is about the Pegasus workflow management system. And what we're going to do is this is going to do slides for maybe half an hour or so. And there's a hands-on bit that you can follow along if you want to do so. So first, some introductions. We have almost our whole team here on this call. So it's me, Mats Runge, Rachel is here, Andrew's here, Shomik is here, and Christina is the one facilitator is missing. So the reason I have this here is I just want to put a face on this. These are the people that are behind the ticket system. These are the people that runs office hours. So really what I'm trying to say is don't be shy, ask questions. And I'm going to talk a little bit more about the office hours and things like that at the end here. And during this presentation, use Zoom freely. I can see the chat, so you feel free to ask questions there. Feel free to just unmute and ask questions, especially a small group like this. This is easy to ask questions as they come up, and you can also use reactions, right? You can use the little raise your hand or thumbs up or whatever you need to do with the reactions. One thing to note is that the slides are already uploaded. So if you go to our documentation here, they are under the training list, and you can follow the slides along. I don't know, can you post them maybe, Rachel, in the chat, and you can also do that. So let's talk about the scientific workflows first. So scientific workflows is generally represented as a DAG. And so the question is then, what's a DAG, a directed acyclic graph? Right? Is if you think about, if you go back to your math classes, right? A DAG is a graph that doesn't have any cycles in it. And that is a really important property here, because one is that that allows this DAG to, it makes it easy to understand the execution path. But it also has a few downsides to it, right? Like, so we can't do loops or we can't do conditionals because the DAG is already defined, and that would break it being a DAG. You can things like loops with sub workflows or rerunning tasks in the DAG itself. So it's not that it prevents you from doing it, but it's the semantics of the DAG has to kind of stay a DAG for this to work. So in this case, the nodes in the graph, those are executables, right? So these are the jobs that we want to run, just like a conjure job. So think about the nodes actually as being conjure jobs, and the edges are dependencies between those tasks. Most of the time, but not all of it, it's a file dependency. So you have, in this case, I see the pre-process task producing files FB1 and FB2, and then we can use those as inputs in jobs further down the DAG, right? And the way that these work is that, you know, we are not moving on until this task is done. And so pre-process has to run and come to a completion, a successful completion. And once that is done, then these two fine range tasks are ready to run, and they will be started. So they are not like, sometimes people are asking, are they all running at the same time? No, they're running in order, and the parent task has to finish before a child before a child can start. Now, in Pegasus, so Pegasus is a workflow management system implemented on top of the DAG concept. And it's actually implemented on top of Dagman. So you might have been looking at Dagman, which comes with Condor as a workflow engine already. And And really what Pegasus does is it takes a DAGman to the next level, right? It builds a DAG for you, and it adds a lot of extra sauce to that to make it more powerful than maybe the DAG would just be by itself. So Pegasus, right? It's part of or like built on top of Condor. You can't really run Pegasus without Condor. We just talked about this. They are DAGs with the nodes being jobs, the edges being dependencies. And the dependencies of Pegasus can be inferred, so they could be just if you just list the inputs and outputs of these nodes, Pegasus will build a structure for you. You can also describe these dependencies in an implicit way. You can say that this task is a parent of this other one, and regardless if there's a file or not. And that's useful sometimes when you have things like, maybe you're synchronizing with an external database or something that's not a file, but you can still kind of describe the DAG with those explicit dependencies. A really important concept is that planning occurs ahead of execution. Right? So what that means is that we plan out the whole DAG before even starting the first job. There's really no dynamic step in this DAG, and we can have it with some workflows, but in general, there's like the whole execution is planned out. And the advantage of doing this is that Pegasus has this world view of the whole computation. Like it knows where all the data will be needed. It knows where obviously ordering and all that stuff about the tasks, and it can do reasoning about those jobs and the data placement and the other things. And we'll see a few examples of that in the next couple of slides. But it's like one way to think about this is that Pegasus, the planner part, is like a compiler. Like it can take your DAG, like a compiler would, and optimize it, right? So it can, for example, it can combine jobs, it can remove jobs, it can say like there's some jobs that maybe not necessary. And we'll see all examples of this. But the point is that just like a compiler applies optimizations, so can Pegasus do that to your whole DAG. A really important concept of Pegasus also that the way that we describe the workflows is in an abstract workflow. And that's what we see here on the left side. So the abstract workflow, the reason we call it abstract is that it's not, it does not have any execution environment specifics in it. Right? It's a representation of a workflow that allows us to take this conceptual computation and map it into different environments at different times. So we can map this abstract workflow to OSG one day, or to Amazon the next day, or to your campus cluster. And those are different execution environments. And so the mapping here will be different at the different execution environments. And I will also have examples of this later, but the point is that you take this abstract workflow, you plan it into an executable workflow. And this executable workflow, that's the Condor DAGman, right? This is a Condor DAGman workflow that's executable. But this transform might not look the same every time you do it, right? It depends on the execution environment. It depends on other constraints that Pegasus might decide to render this differently at different times. So in this case, we see that Pegasus have added jobs to it. So it added data management jobs. So for example, here it added a staging job that says we need to grab data from some external source and then make it available to workflow. Similarly, at the end, there's a staging out and registration jobs that's been added. The cleanup jobs are interesting. This is one of the things where this worldview and reasoning about the workflow can help you. So Pegasus, because it knows where the data is not needed anymore, it can decide to just insert cleanup jobs in different places of workflow. So the reason this sits here, right, is that this task had some input, some file that it used, and after it's used here, it's not used anywhere else in the workflow. And so Pegasus says, well, if we're not going to use it, we might as well clean it up. And this is, for some workflows, this doesn't matter at all. But if you have, for example, a large bioinformatics workflow or stuff with large data, these cleanup jobs can really help you maintain like a sane footprint on disk. So the way that we describe these workflows is with code. And there is an API, or we have different APIs. We have Python, Java, R, and there's a specific Jupyter API as well. And the reason we do this in code is basically scalability. A lot of the workflows that we are using Pegasus are just too big to do things like with the graphical editor. Like you can't just draw like a million nodes and kind of keep that sane. So doing this in code, it's a little bit extra work because you have to learn a new API, but it also makes a very natural way of specifying these workflows. And we'll see this in the hands-on section on how you do this later. For example, based on inputs, you can generate jobs, right? The abstract, the actual representation is YAML. So we have different ways of like different files, but this is what the workflow would look like in that abstract form that then gets transformed into an executable workflow. We have the interface to Pegasus is mostly command line. It's not the only thing, but it is the most common way. And so the command line tool, some of the stuff we're going to use today is there's a Pegasus status command that gives you status of a running workflow. There's a statistics command that pulls out provenance information about the jobs and the workflow and can summarize that in different ways. We're also going to use that in the hands-on section. So in this example, for example, it has the number of succeeded, failed, retries. All this stuff is presented in a summarized view here, and we'll talk a little bit about tasks versus jobs also a little bit later here. And the last command on the slide is Pegasus Analyzer, and this is one of these tools where you once you start using it, you get a little bit dependent on it. And what it allows you to do is to dig into workflows. If there's any failures, Pegasus Analyzer will pinpoint where those failures happened, and it will show you the errors, right? So instead of trying to grab through logs and trying to figure out what job failed and how did it fail, Pegasus Analyzer is kind of a shortcut. It will show you the jobs that failed. It will show you the standard outs and error, and maybe even give hints on what you can do to fix it. So it's really, really useful. So the next couple of slides are some of our success stories, and I'm not going to talk about everything about success stories, but I'm going to use them to highlight some of the kind of the features that you might find useful. So the first example here is LIGO, and LIGO is obviously it's one of our big success stories, but it's also really important to us because LIGO has been one of the feature requesters that drove Pegasus development for a long time. So what I mean with that is that LIGO came, asked for features, and then they became general features in Pegasus that you guys can then take advantage of. And so if we look at this picture, what we have on the left, we have this abstract workflow up here, 4 nodes in a diamond shape, right? The Pegasus planner plans it into this executable workflow and hands it over to Condor for execution. one of the things I want to point out here is that like we have this task J, for example, and it's done here with an extra ring around it. And what happens is that not only did Pegasus, add jobs to the workflow, but it also added some wrapper stuff around J. And if we then somewhere in OSG zoom into this task, the J job, we zoom in with this magnifying glass, and we'll see that even the job looks like a little mini workflow, right? There are multiple steps inside the job. It's just not running your task. What it's running is data management, for example, is maybe pulling some files in from some external storage. It's running J. It's pushing stuff back to somewhere else, and it does some cleanup and actually color code on here, stage in, stage out setup. And there's even more stuff here. And the other thing that happens is that when J runs, it's running inside a provenance collector. So it's a special task that wraps your executable and collects useful information. For example, it collects the environment that the task ran in. It collects things like runtime and different modes of that runtime. It collects memory usage and files in and out, right? So the point is that then all this information goes back into Pegasus in a little, per workflow database, and we can then pull out all that information, and that's what the statistics command did, for example. But there's more information than that's available to you. Another example is CNNT. This is running an OS pool right now. What I want to show is actually a better statistics here, right? So this is what we want to see when we run the Pegasus statistics command. So in this case, the workflow took 5 hours, but it actually did 136 days of compute, right? So like this is the speed up that you will see in bigger workflows. When we run our little test workflows later, there's a good chance that the workflow will actually run longer than the summary of the time, right? And you ask yourself, why would I run a workflow if it takes longer to run it than actually just run the different executables one by one? Well, because when the workflows gets big enough, that's when you actually see the real advantage of them. The other thing you will see here is that some of the tasks in this workflow retried. And this doesn't really tell you why, but at the end of it, we had no failed jobs, everything succeeded, and this workflow was all good, right? Another example, the Event Horizon Telescope. The reason I like this one is they use an external data source for the actual data that they do compute on. So the jobs they pull from this, and it happens to be Cyverse, which is now called, what's it called? What's the new name? Well, anyways, there's a different name for Cyverse. But this is a big kind of cyber infrastructure project in Arizona that provided storage to this project. So instead of like making copies of this data in different places, all they do is that they point Pegasus to saying, do the IO directly against this storage. So this job will start somewhere on OSG. The first thing we'll do is pull data in from Cyverse using the protocol that they have available to them. And it will do the compute, and at the end, it will push the data back into the storage system. And this is something you can do even at a smaller scale, right? If you have storage, for example, on your campus, this will allow you to pull and push directly and not even have to copy to OSG before doing the compute. So it's a time saver that way. And the last one, I want to give an example that's a little bit more, not one of these huge projects. So this is from Conan Ask, who was he was a summer school or OSG user school attendee. In I don't even remember when it was, but let's say early, like 2020. And he came in and he already had a DAG that he ran successfully in OSG, but he still felt like, to scale this up to make the computation even bigger, he switched to Pegasus, and it wasn't that big of a switch, right? Because he already had a DAG, he already had it kind of written down on the whiteboard. And he ended up with this little workflow you see in the bottom here. And just like I told you before, that it's some ways difficult to, you can't draw these workflows by hand, maybe because they get too big. The same thing happens when you want to visualize them, right? Like the small example ones, like this is actually easy to visualize. But like if you had, like, 500,000 jobs, this would be a really, really wide slide, and you just wouldn't be able to see anything, right? So a lot of the time we can visualize the small ones, but when the real big ones, it's going more and more difficult. And one of the things that's interesting about this, look at all these dependencies it has on this level up here, right? This is a lot of different cross dependencies that's getting really difficult to, again, draw by hand, but doing it in code makes a lot of sense. The big win for Connor was really kind of the retries and the file transfers. Like as I said, this diagram before, but moving to Pegasus gave him a little bit more, handing off some of this boring stuff to the workflow system. So before I go to talking about more features, are there any questions? Okay, we'll just keep going. So let's talk a little bit more about the features of Pegasus. I said that we had an abstract workflow that gets compiled into an executable workflow for that specific environment. And to fill in those blanks, to tell Pegasus what is that execution environment look like, where's software available, where's data available, there's 3 catalogs that we have to provide. And so one here is the site catalog, which describes the execution environment, right? So in OSG, we're saying, hey, it's a Condor pool. We're saying that there are some storage available, maybe, and where that storage is. Transformation catalog describes what executable you want to run. So it will, like if you provide a script or if you provide a container, that's described in transformation catalog. And the replica catalog describes available data. So at the minimum in the replica catalog is the input files for the workflow. It could be more stuff, and which I will describe later, but at the minimum, the replica catalog describes all the inputs to the workflow. If we look back and we look at LIGO, for example, one of the things that they do that's really, really neat is that they can have multiple files available for the same kind of logical file. So if the workflow says, I need a file called a.data, that could be, that a.data can exist in multiple locations, and Pegasus can pick based on that, right? So what I'm trying to say here is the replica catalog is one-to-many relationship. And so when the workflow starts up, or when the job starts up, it can say, there are 3 different locations for my input file, and I know how to order or decide which one is the closest, which one is the best, fastest, right? And it can pick between them. So again, this is really useful if you're running in a different environments at different times. If you're running, let's say in Amazon, and there's a file that's already located in Amazon, there's no reason to go outside and pull it in from somewhere else, right? And that's why this replica catalog, multiple entries, can be useful. However, for most people, it's a one-to-one, right? We only have one copy of our input file, and we don't really have to worry about any selection because there's only one file available. There's also different data staging configurations, and in OSG, we're doing the 2 first ones here. So we can run the workflow in what we call the Condor IO mode, That this means that it's just like your jobs when you do file transfer input files and output files. It's really easy to set up, right? There's no credentials. Control takes care of all that stuff. But the downside is that we are mostly limited to the submit host when we do this. And there are some exceptions like OSDF and stash, but in general, all the data gets pulled and pushed against the submit host. The non-shared FS is much more generic version of that, where we can put data anywhere. And it's what's really powerful about this is, for example, credential handling. So you can put stuff in Amazon S3, or you can OSDF or anywhere, and Pegasus will handle the credential management. It will handle the transfers for you. And this is a good example of that Event Horizon example I gave, where data gets pulled and pushed against Cyverse. And so we can either do it via iRods, or we can do WebDAV, and Pegasus will just do those transfers for us. Shared FS, we don't really do in OSG at all. That's just really for your local campus cluster. It has a shared file system, so it's not really relevant to us. But it is there if you want to. Again, you could plan that abstract workflow to a shared file system, and that changes drastically how we do data management, right? Because we will utilize that shared file system and put data on there and manage that way. So I've talked a lot about this already, but doing the data management is a huge part of Pegasus, and there's a internal tool called Pegasus Transfer that we use a lot. So this is added into the workflow. But a few things that are really cool about this. First, there's a bunch of different protocols that you can speak, right? That's one advantage here. But the other thing that's kind of cool is that it can do two-stage transfers. So it can do things like grab stuff from a grid FTP server and put it on an S3 server. And these are, generally two incompatible protocols. There's really no client that can speak both of them. But Pegasus will instead do, two steps transfers for you. And it's obviously a little bit slower, but it is really, really convenient when you work with different data storage systems. And for example, you might go to your local campus IT and ask, what is the best way for me to transfer stuff in and out of campus? And it will give you some protocol, and you say, well, that is not really what I need, because on my other side I have Amazon, but Pegasus can still decide to transfer them in two stages, and you don't have to worry about it. The other thing is parallel transfers. It's a threaded tool, and even things like let's say HTTP, right, which is not really threaded in the protocol itself, we can do really good performance because we can run multiple transfers in parallel. And this is, in general, this is actually so powerful that we have to be careful about it. The data sources that we deal with sometimes, we can easily overwhelm them by doing these parallel transfers. So sometimes we have to be careful and think about, what is the actual limits that we have to deal with when it comes to pulling data, and then before credential management. So this is internal, but it's a really good tool to kind of know about, because it enables you to do things that maybe Dagman by itself wouldn't be able to do. So the other thing that's pretty common on OSG is that you have really short tasks, right? So I'm trying to say is that each one of these little nodes here, maybe these are just a few minutes long, right? And if you look back to what we facilitators told you, that like what's the best case job, 30 minutes to like, I don't know, 5-6 hours or whatever we say. The point is that if they are really short, you spend a lot of time over like scheduling them, right? So if that job is only a few minutes long and it takes 30 seconds for you to schedule them, that overhead is very noticeable in your performance. Instead, what you can tell Pegasus to do is to say, I just want to cluster them together. So instead of running them one by one, make a bigger cluster job that will improve our performance. And that's one of the things that we're going to do in the hands-on section. But this is a very, very common thing for short tasks on OSG. Another one is that any node in the DAG can be another workflow. In general, I don't recommend this unless you really need it. This was implemented as a way to kind of provide even better scalability, right? The thing that happened at the same time is that DAGman has improved, and this DAG here, the top level one, can be really, really large before you run into problems. I mean, we're talking about hundreds of thousands of jobs before you even get into trouble here. But the other thing that a sub-workflow allows you to do is recursion, right? So you can say this job here, plan that as a sub-workflow, and then this one as another sub-workflow. And so this is one way to do looping or recursions. Now, sub-workflows are way more complex than a single workflow. So that's why I'm usually saying, hey, don't use this unless you really, really need it. But if you do need it, it's there and it works really well. So another common thing that we see is pruning of workflows. And the idea here is that if you have a workflow that has partial data available already, I'm circling back to that replica catalog now, right? Where we had, I said, like it contains inputs, but it could contain more data than just inputs. So in this case, we have partial results from maybe another run before, or we have an overlapping workflow. And what Pegasus does is that it prunes that workflow at planning time and saying we don't have to rerun these because we already have the results for these tasks. And so what ends up happening is that your workflow, executable workflow, only runs those jobs that you actually need. And obviously, saves recomputation time. An example of where this is useful is if you have overlapping workflows. Let's say every day you run a workflow for the last week, right? So every day, you calculate in today, but the last 6 days that you already have data for, and you can keep on pruning the data and just rerun like the actual jobs that it needs to. The other time when this is really useful is that, let's say you have a workflow that you want to rerun with some parameter changed, and then you can just do partial inputs and not rerun the base jobs. Another part of Pegasus and DAGs and I mean Condor in general, right, is how do we handle job failures? And in Pegasus, the most basic case is the POSIX non-zero exit code part. So this is what we use in standard Condor jobs as well. Non-zero exit means failure, and then we'll have to deal with it somehow. And there are other ways. For example, you can also tell Pegasus to look for keywords. So let's say that you have an old crappy code that doesn't use exit codes, but the last line says, success or failure. We can also do that, use those kind of parsing and keywords to decide if the job failed or succeeded. If you have a failure, well, job retry is the default way of handling that. Works really well on OSG. Like sometimes we have sites that maybe caused a failure. Rerunning the job there's a good chance that will work. and that was what we saw in that Xenon NT workflow, that it had 260 something failures. They were rerun and then succeeded somewhere else. We do have support for checkpointing as well. This is application level checkpointing, where you specify that if this job can output the checkpoint, then we can start from that previous checkpoint and not redo work over and over again. And the last thing to know about is rescue DAGs. So this is a feature that's also available in Dagman, obviously. The point is that the workflow will try to get as far down as it can. But if it exhausts the number of job retries and there's no way to complete, the workflow will stop, but it will keep that state, right? So let's say that OSG is down for maintenance for a day. The workflow will stop. We can't make any more progress, and it will just write that state to disk. The next day you can come and you can start the workflow up again from that point, that point where it failed, and it will just keep going, right? So again, the point is, it won't rerun jobs that are already completed. It has that whole state in it, and it will just continue like nothing have happened before. And another thing that is kind of internal to Pegasus that we're really proud of, but is kind of hidden, and most people might not even know it's happening, is that we do integrity checking of the data. So the way that this works is that the first time we see a piece of data, we calculate checksums, and then whenever we touch that data again, we verify the checksum. And so in an example here, like this is the same kind of zoomed in thing that we saw before, where I said it even a single job, J1 in this case, looks like a little workflow, right? But now you see there's two additional jobs here, two additional, it's not really a job, two additional steps, right? And so in this case, we check the integrity data of the inputs. And when the task is complete, we generate new checksums for the data that was generated, and then that's carried through, right? So let's say that this data gets staged out, staged in again, right? So this step here validates the checksum from this step up here, right? So it carries through the whole workflow. And if there's an integrity check that fails, that will stop. They will fail this job. It will go back to what we just talked about, retries and stuff like that. If it still can't complete, it will stop the workflow and let you deal with it. This is the idea here. The whole idea is, don't do compute on data that you haven't validated, that is not don't do compute on incorrect data, right? That's what I'm trying to say. This can be disabled, but it is really, really useful. And it's really useful if you do a lot of data transfers, like in and out, in and out, in and out, right? And because no system is perfect, thinking that your data, even sitting on your own hard drive, is not prone to maybe errors getting introduced into this file at rest. It does happen. There are papers that, like, we are referencing it when we did this work, where they have shown that, for example, on Exceed, there was a bunch of switches that were problematic, that introduced errors silently into the data transfers. We had this on OSG Connect many years ago, where we had a bad, if I recall correctly, I think it was a bad network cable that corrupted files. And so, this does happen. And the bigger your data set is, the more careful you have to be about data integrity and kind of making sure that nothing has changed since the last time you used that data. So this is the end of the actual slides. I wanted to just leave you with a few ways of getting support from Pegasus. So there's a website that has a user guide and all that stuff. There has examples and a lot of different example workflows you can download, see what other people have done. There's two mailing lists. There's users, which is an open mailing list. You can just do discussion. There's a support one that you can email just to developers. This is useful sometimes if you have, something like an issue that you don't want to publicly be visible. You can just email Pegasus support. There's a specific Slack for it, so that's another way to do it. And then YouTube channel, obviously. So the next thing we want to do is this hands-on demo, but I'm going to, again, ask for questions before we get into that. Any questions?
Yeah, I have a question.
Go for it.
With the, like you mentioned, the job pruning, capabilities, how does that work? I guess, is it just figuring out what's already been done and moving forward like a rescue DAG, or is it considering the
No, it
possibility
has
that you
nothing
might
to do
have
with that rescue DAG. It actually, all it does is look at the data, right? So,
okay.
so if we look at this, the right-hand job here, you can see my mouse, right?
Mm-hmm.
Yeah. So the right-hand job here, right, produced some file that created this edge, right?
Yeah.
So when Pegasus comes back later and says, the data that is produced is already available somewhere, and it's listed in the replica catalog, that's where it's getting it from. And it says, if this is the only data that this job produces, and there's no need to rerun it, we already satisfy the inputs for this job, right? And so basically it does a backward traversal and says, where can I find jobs that are no longer needed?
Yeah. Okay.
Right?
So if a job just needs a certain piece of data and it can come from anywhere, is that a way that you can kind of make more ambiguous workflows?
So first, Pegasus, it's really good at reasoning about data, but it only knows about files, right? It doesn't know about collection of files. It doesn't know about partial files. So either you have this full file or you don't, right? I mean, there's no halfway about it. So for example, let's say there's 100 files coming out of this one. If you only have 99 of them, we still have to rerun this job, right? It has to satisfy all the outputs for it to be marked as complete. So, and I actually see there's edges missing here. That's confusing. Sorry about that. It's probably this one. I don't know what happened. But the point is that, no, it's all in the replica catalog. And this feature is, when you need it, when you have this overlapping workflows, it is really, really neat. I mean, it's really, really useful. I have seen people do things like they figured out that these jobs ran with the wrong parameter, right? And they basically go back into the replica catalog and takes out everything that these produced, change the parameter, and then they start a new workflow with it. And I would say a lot of the time, though, is that people time is more expensive than computer time, and sometimes it's just easier to rerun the whole thing instead of just of trying to figure out how to prune it correctly. But yeah, it's like the time series is where this is really useful, predicting weather, things like that, where you always do an overlap in the computation, and then this can be really useful. Okay.
Got it. Thank you.
Other questions? All right. So, okay, I'm going to paste stuff into here first. So the first one is this is the tutorial that we're going to do. It's also available on our website. I think if you just go to, if you just search for Pegasus, it should be enough. Yeah, Pegasus workflows. And the way that this is really set up for a self-guided tutorial, but we're going to step through it together. And the way that this works is that somewhere on login 04, login 05, one of our access points, you clone this repository, and that gives you everything that you need. So I'm going to do that out here. I'll do, oops, what's happening? So I'm going to start, let's do that git clone. Oh, okay, I've been here before. Git clone. And I'll cd into that. Pegasus, and there's a word frequency example in here that we're going to use. I'm going to paste that command as well. And if you're following along here, and if you get stuck, just interrupt me. There's really no way for me to really know how if I'm going too fast or too slow. So, just let me know. And if we do an ls in here, we'll see a few things. This is a very typical setup. We have some Python code. We have a workflow with Python, and we're going to step through that. But this is what generates a workflow and actually submits it as well. But this is the kind of the main part of what we want to do. But if we look in bin first, there are two executables. There's a word frequency and there's a summarize. And what we're trying to do is, we're trying to make this workflow here. I know this is small, maybe too small to read, but the inputs here are a set of ebooks in text format. So Alice in Wonderland and Dracula, right? And we're going to run the word frequency tool executable on it. What we'll get is an output file based on the input that has the frequency of that book. And then we're going to summarize all those findings into a summary.txt file. So a very simple workflow. And zoom in a little bit makes it maybe even better. And so these inputs here is what we can find in the inputs directory. So we can look in the inputs directory. We can look at one of those files. Right. So it's just a textbook, a text version of that ebook, right? All right. So what we're going to do is, I should say there's also many more inputs. There's a bunch of textbooks, like 1,000 of them in this directory. We're going to get to that a little bit later. Okay. So if we start looking at this, let's open the workflow PY and step through it and kind of look at what's going on in here. So the first thing you will see is that we do import the Pegasus API. This API is what's going to help us build the different things that we need. And if we go back to the slides, what we need to do, right, is the first thing we need to do is this abstract workflow. This is what we're going to do, word frequency and summarize. This is what we're going to use the API to build. But we're also going to do these catalogs, the site catalog, transformation catalog, and replica catalog. They don't have to be in the same file. They don't have to be built with the workflow like we are doing in the example, but this is a very convenient way of doing it. You could actually generate these like even by hand, or you could use a different tool to use API to generate them. But in this case, we're going to do everything in one file, everything in one go. So the first section, there's a property file. This is also not really required, but this is kind of controls a few how Pegasus behaves. One of the things you should know is that the workflow does send events into a kind of what's it called? A performance database that is central, like that Pegasus developers can see. And the reason we do this is to just know that people are doing the workflow. We get some statistics, and it helps our funding agencies, for example. This is totally optional. If you don't want to be tracked, just don't do these steps, right? But if you don't mind, we're happy if you leave them in, because as I said, it will help Pegasus development in the future. The other thing they want to see with this is that we can give, for example, Dagman properties. So in this case, the max idle, really useful property if you have large workflows. In this case, we say, regardless of how big the workflow is, only keep 1,000 idle jobs in the queue at any given time. So an example of this, right? So let's go back to Connor's workflow. So he has 500,000 jobs, or almost 600,000 jobs, right? If he just dumped them into the Condor queue, there's a good chance that myself or one of the facilitators will contact you and ask you, what are you doing? Right? That's a lot of kind of pressure in the queue, because you're not going to have that many jobs running anyways. So a nice way of dealing with that is the max idle. So what that does is that it will only put those 1,000 jobs in. It'll maintain it, so it will maintain pressure. Like you could have, many more running than 1,000, but there will only be 1,000 idle ones at any given time. Here's also where we set the different data configuration. We're going to use non-shared FS, and we're going to use Stash or OSDF for the data in this workflow. All right, so here are the catalogs. The first one is a site catalog that describes the execution environment. This is by far the worst one, but it's also the one that you probably never have to do. You just copy this and you keep it the same all the time. There are 3 different kind of sites that we're describing here. So there's a local one, which is the submit host, with saying where can I store data on the local one. There's the OSDF one, which is the stash. And the reason this is a little bit ugly here is that we do different things based on what different access point you're on. So we're going to be on OSG Connect. So this is the section for OSG Connect. If you were on the Wisconsin access point, paths and stuff might be a little bit different. But one thing to notice here is that the reason why we kind of want to generate these, why we want to build these at runtime, they have things like users and stuff in the paths, right? These are things that for you doesn't change. You could generate this once and be done with it. But when we do a workflow that needs to be shared between different users, well, there are things in the paths that change, and that's why we generate this on runtime. And the last one is the Condor pool. This is what we're actually describing the OS pool, right? So this is a Condor pool. We want to run with Singularity, and we want to run this image down here. So the general concept here is that we can set profiles on individual jobs. We can do it per site, and we can do it per transform. So things like this, right? Like how many CPUs and disk we want. We can do that like across the whole workflow and saying all my jobs will have the same thing. We do it on the site. if we wanted to say it, when I'm running word frequency, it has a specific set of requirements. I could do it on that one, or I could go down to the individual job and say, I have a specific job that needs way more memory, and I could apply those attributes to that job only. For 99% of people on the OS pool, they do this, right? They're saying all my jobs are the same, all my jobs need the same requirements, all my jobs need the same container, for example, right? And what we do then is we write this out. So once we're running here, we're going to step back in and see what these looks like written out. Rachel, question.
Yes, I have a question. So just to confirm, you can set kind of this like Condor pool wide specifications for your job, like that every job will have one CPU, 1 GB of memory, 1 disk. But then let's say you had like a single really large node or job later on, you can set a specific requirements for those ones.
Correct.
And those will write over the default ones, correct?
Right. Yeah,
okay.
Correct. And part of this is that sometimes this is the old Condor thing about the knob for everything.
Mm-hmm.
Sometimes it's confusing, right? Like sometimes it's just it's more difficult to keep track of all that stuff than it is to kind of do it once. But there are, like, a good example of this is bioinformatics. Like, we have bioinformatics workflows where each job varies a lot in number of cores, number of memory, maybe disk required, or what image they want. So, sometimes you have to do it per job. Sometimes you can just get away with doing it across the same, like same across all the different things. And we're going to look later and see, for example, we're requesting 1 GB of RAM. We will see later on in the provenance data, and we'll see if that is a good estimate or not. And we can maybe adjust it based on that.
Okay, thank you.
The next catalog is the transformation one. So remember, this is our executables. We already looked at that bin directory. So there's a bin word frequency, and there's the summarize one. So those are 2 executables we have. It's a little bit verbose here, like, what architecture we want and things like that. But like, this is, you don't have to set, for example, architecture. It's assumed to be the same as the execution, like the submit host, if you don't do this. But one thing that you will see is if it's stageable or not, right? And it's really kind of saying, is this something that's installed already, or do I need to bring it with me? In OSG, right, we always have to bring stuff with us, right? But the exception to that is maybe the executables in our container already. And if it's in our container, there's no reason to stage it, right? We just have to specify where in the container it is. But in this case, it's just a simple script. I think Perl will just bring it with us. All right. And then the last thing is the replica catalog. So again, this is a little bit of extra Python in here. But the idea here is that we take everything in the input files, right? And we add each one into the replica. And there's 2 kind of arguments here. There's an LFN and a PFN. And I just want to explain what those are, because this is again a concept that you might not be using otherwise. So logical file name is a file name that just describes the file, does not describe where it is or anything. While a physical file name is a URL, right? It's like a location of this file that we can find somewhere. So this is the mapping I talked about before. Logical to physical, if we could look back at the slides, right? So in the case of, I think I had a slide on it, didn't I? Well, we can look at this one here, right? So these things here are the logical file names, right? Like, these are just saying, I need a file called a.txt. And then when we do the transform here, actually the logical file name here, So there's no path, nor URL, nor nothing to these files. They're just a handle. When we do this, the planning, they get filled in, and we're saying, okay, if I need this file, I'll look in the replica catalog and look that up and find the place where I can find it. And we'll look at that when we look at the written out replica catalog. I think it will make more sense. And then we are down to the workflow. And the workflow part, you know, this is the simple part. This is just a few steps here. We do it backwards in the sense that we define the summarized job first. And then for each input file, we create a word frequency job. And the reason we do it backwards, right, is because for each job of these, we want to add that output of the word frequency to the summarized job. So then we go look at the picture here again. So when I'm saying we do it in the wrong order, right, is that we define this job first, and then we define all these. And the reason for that is that when we define this file here, which is an output of word frequency, is an input summarize. Okay. But the one thing to note here is that we never, we never say what the relationship is. All we're stating is that this word frequency has an output file, and that output file is an input to summarize. So what we're doing here is that we're just describing inputs, outputs to jobs, and then we're letting Pegasus infer the different dependencies between the jobs. Like, you will figure it out. Okay. And then the last thing we're doing is we plan this whole thing, right? So we're planning it, we're telling it what site are we executing on, what are we using for staging, and where do we want outputs to go. So the way to read this is saying, I'm going to run on the OS pool. I'm going to use OSDF. Like when I'm running on the OS pool, I'm going to use OSDF for staging. I'm going to want the output files to come back to the submit host, and I can look at them there, right? And then also I'm going to submit. So we're going to run this. Finally, we get to run a workflow. So when I run this, it does the, you know, the finding the workflow. It says I'm writing this to a workflow YAML file, and then it plans it out and it executes it. This here is just a Dagman output. If you run Dagman before, this is the Dagman output, right? The difference is at the end here is it gives you commands that you can use to monitor your workflow. And one thing I want to point out is that it gives you saying, it doesn't give you a job ID, it gives you a directory. And the reason we're using directories instead of, for example, job ID, right, is that we want to be able to interact with this workflow before it's running or after it's running, or when, you know, so a job ID would just sit in the queue and then go away, right? And then we would lose that handle. This is a handle that's valid for the whole time. So let's just do run Pegasus status and see what the status of our workflow is. So what it will tell you is, it will tell you, here's my workflow. It will tell you the jobs that are, you know, currently in the system based on that. And then it will give you a summary at the bottom about, you know, the different states. And I'm going to do the same command, but I'm going to add a W, -W, which means that we'll keep on running and kind of showing us the state as it changes over time. And the most interesting thing for people are usually, you know, how close am I to completion? In this case, 15%. The different states here, right? So what is an unready state? That means that those jobs are in the DAG that I haven't gotten to yet. Like, they are not ready to run, right? And the reason for that is that the parents haven't run yet. So we'll look at the picture again. So for example, if I'm running this job right here, right? all these other jobs below it are unready because this one hasn't completed yet, right? We haven't, and once they're ready, like if this has run, now this row is ready and everything else below it's unready. Does that make sense? And as you will see here now, they started completing. Also, ready means that they are, and you might see if you're running that max idle, if you ran a lot of, if you had like max idle set to 100 or something like that, you will see ready jobs that are ready, but they haven't been submitted yet, right? They're not in the queue yet. This is a kind of a small workflow, so it's not going to kind of show you all that, but that's how where those are useful. And the other thing to know, these are just normal Condor jobs, right? So we can also use the Condor tools to look at our jobs, and you will see them in the queue here. It's just normal Condor jobs, right? Now, while this is running, you don't have to you just have to look what I'm doing, not follow along. But if we look at one of these jobs, so we can look at one of the word frequency jobs, for example, right? So these are a lot of stuff that Pegasus have kind of, this is a submit file that Pegasus generated. There's a lot of stuff in here that some of the stuff should look familiar to you, like output and log and error, right? It does the request stuff. And there's other things like environment and singularity image, like it fill all this out for you. Similarly, if we look at the actual DAG, it just looks like a normal DAG, but it's more complex than you maybe are used to, right? So we can look at, go down to one of the word frequencies again. So here it is. There's a submit file for the word frequency. There's a postscript that where we use for checking the exit code. There are priorities added, there are retries added, and just like it, it's still a DAG. It's just more complex than maybe what you would have written by hand. Let me see, what else should we talk about when we're here? Okay. Well, let's look at Pegasus status again. Still idle. We'll come back to that part. Let's go down to our tutorial again. And while that workflow is running, I want to show you that in that directory we're working on, we worked the workflow with PY. These files have gotten written out, right? So there's the properties file. Here's a replica, the site. So we look at sites first, for example. These are the description of the sites. Here's the local site. Right, here's the OSDF one. So if you look at OSDF, right, it just maps my public directory to a path, like a base path of OSDF that the workflow can use to do the staging with. If we look at the replica, as I said, we should look at this before. And so here's the mapping, right? So what Pegasus knows is that for this file, if it encountered this file, a reference to this file in the workflow, there's a physical file name, there's a location where this can be found. And so in this case, they're just references to something in the file system, but this could be a URL. So this could be, I have mine on HBS somewhere, right? Like it doesn't have to be a local file path. It could be a remote location that it knows where to find the data. And the last we can look at is the workflow itself. So this is the abstract one, and we can look at one of these jobs. So let's look at this part. So this is a word frequency job. It has some arguments. It has an input down here, right? This is the ebook input, and then there's an output for with the same file with the .out extension, right? And it also has a few flags that is saying, you know, stage this out. So you can decide if you want to keep those files or not. This is useful if you have a large workflow and you don't care about intermediate data. And maybe you only care about the final data. And then you can say, okay, don't stage this out. And this is when Pegasus cleanup kicks in, because then it can decide if you don't want to keep that file, then we can just clean it up as we go and delete files, you know, because we already used them and get them past that point in the workflow. So let's do one more Pegasus status and see if we have going to import that. Oops, oh, still idle, of course. Okay, we'll take one of my previous runs, and we'll just show you what it looks like. So this is a workflow that has finished, right? 100% done. And one of the things we can do is we can do Pegasus statistics. And I'm going to do a little bit extra. I'm going to do summary all. Okay. And when I do this, the first thing we get is this. We saw that on the slide before, where you know, we see the summary. We had 7 tasks, 19 jobs, and these took 3 minutes to run. But the summary of all the calculations we did is just less than a minute, right? So this is what I talked about for demos. It took us 3 minutes to do 1 minute of work, and obviously this is not great, but you know, you don't have to do a lot of calculation for this to flip in your favor. The other thing to look at here is jobs and tasks, right? So we had 7 tasks. These are the summary and the word frequency. Pegasus made 19 jobs here, okay? And this is the staging and all this stuff that needs to be done around the workflow. The same thing here is that this seems like an excessive amount of jobs to only run 7 tasks. It's just for demos, right? Like if you scale this, we'll actually do it, but I'll get back to it in a second. For bigger workflows, this again flips in your favor. The other thing that we get when we run the summary is that we can look at specific details. So we can look at a breakdown here of our tasks. And I know this renders poorly because of the width of this table, but like we can look at a table here that has the transformation, and then it does, for example, runtime and memory. So in our case, let's look at frequency, word frequency, and we'll look at the mean runtime, which is less than, like it's 1/3 of a second, right? It's not impressive at all. There's a total, but we get means and minimums and stuff like that. So really short job. In memory, we can see this is, you know, used 4 gigs of memory, which is, again, you know, we asked for 1 gigabyte, we use 4 megabytes. We're way off, like way under what we actually requested. And the last feature I kind of want to show you to deal with this is one of the transforms that we can do, and that's the clustering. So if we go back down to the workflow tutorial Pegasus, word frequency. So I'm back here, right, where we see the workflow. I'm going to copy all the many more inputs into inputs. Okay. And if we look at the input directory now, and we see how many files we have in there. Now we have 1,000 files, right? So now we will expect there to be 1,000 jobs. And we can actually just submit that, right? It's just a 1,000 job workflow. Actually 1,001 because of the summary job. Right? And we can do Pegasus status on that. And there's a lot of jobs here sitting idle. The problem with this workflow is now that you remember we talked about how these are really, really short jobs, right? And that's a silly thing for us to do because we know that we're going to have all the scheduling overhead to deal with. So what we can do, if we go back into the workflow PY, we find the transformation catalog, right? So we're saying, we're saying for the word frequency tool, let's add a profile and we say we'll cluster this because we know they are so short. Let's just make them longer, right? So we'll cluster them together. We can change this to, let's say we'll run 50 at a time. And we'll do a new workflow. We still have 101 tasks. I think so, right? And if you look at this workflow now, right, we'll see there's only like 37 jobs. So we went from 1,500 or whatever that was, to 1,300 jobs to 37. And each one of these will then contain 50 of the word frequency jobs. So this is a really, kind of an example of the powerful transforms that Pegasus can do on your workflow. If you, and then, like the extreme case of this is, let's say you want to run a high throughput workflow on a HPC machine that only wants parallel jobs, you can cluster a whole workflow into one job. Right? So you don't have to, that's kind of a special case, but it is the extreme one where you're saying, I'm going to on that Slurm machine, it will look like just one big parallel job is running, but really what it is a bunch of small tasks running. So it allows us to kind of transform these workloads from dependent on the execution environment that we have. We can tell Pegasus to transform it to run better in that execution environment. So I'm going to stop there. We have 10 more minutes if there are any more questions.